Hello there, so we've got another set for Alan, and it's a Midland 77104 UK. It's a August 89 one, so I'm sure the DUK version must have come in very shortly after this, so this could well be one of the last ones, which is the ordinary UK version. I'll tell you what, we'll put it through its paces before opening it up. He says on his paper, Baby Midland, works but needs a tune-up. So we've got a factory original mic with this. Right, well, I haven't got any power coming to it, so what's gone wrong? Well, we've got power there. So he's got this kind of extension-y bit. Not sure we've got power there. So let's just have a look at what his fuse is doing. Oh, wow. It's not the right kind of fuse, is it? So it's all corroded. So what fuses have I got on my bench? These are 10 amp ones, they're no good for CBs. Oh, avalanche of meters. With about 10 pairs of glasses on, I might be able to see what these say. Three amp, that'll do. So it's 10 amp ones in business radios, because they're usually the VHF and UHF radios we do tend to be 25 watt. Right, so there's something extra to do, and that's to make sure it's actually clean. So it's had a corroded fuse in it. I've just put my fiberglass brush down there. So let's see whether that brings back normal results. Fine. So you can see how corroded that fuse is, and well, it must be 20 amps or something, that. I don't know. But look at the width of that. So, fuse. So, obviously it worked for him with the corroded fuse in it, but what would happen when you're going to transmit it was probably going to current limit. Okay, picture in picture on. Good grief. Oh, I don't know what channel we're on yet. 27, that's no good to me. So this is the one, this is the better one, because the DUK starts off on channel 9 because of the phase lock loop chip in it, and it's a rotary up-down switch. It's not a proper BCD encoder like this is. So this will always stay on whatever channel you leave it on, and that's why they can put 9 on the case, whereas on the DUK version, because it's really an up-down, 9 can be anywhere. So that is the one to always go for if you can. It's to do with receive, not transmit. These are more sensitive. So there we go, channel 20. Let's try keying up again. I'm going to say 3.85. Channel 40. 3.6. And channel 1 is probably going to be 4. 3.9. Low power. Go back to channel. They're not very locking, are they, these locking plugs? I'll do it on this factory original mic. Unless our Maxon one fits. Yeah, our Maxon one fits. So we'll do everything on the Maxon mic. I mean, at the end of the day, it's a Maxon radio, but I didn't think they were the same pin out. There you go. Does it say so on our sheet? I can't speak. So we're looking at 9 for Maxcom 4Es, etc. So baby Midland. Yes, it is the same. It says so on the sheet. Good. I've only done this 40 years. So we're back on channel. We will be back on channel 20 when the mic doesn't unplug itself. And on low power, the radio is doing 240 milliwatts. Back to full power, and it's drawing 970 milliamps. Nice and efficient. Deviation, if our meter's not playing up, wallow. This is 2.8. We won't be doing the VCO, and let's look where it is on frequency. Test set's been on for a couple of hours, so we don't need to take anything into consideration. I don't seem to have any colour on that camera. Perhaps it's coming unplugged, or the transcoder from S-video to whatever is in the wrong mode. Like NTSC instead of PAL. See how bothered I am. 27791. It's not off frequency, but we'll pull it up. 2779100, and of course it should be 125. So with that in mind, we will put 27791 into our signal generator. So deliberately putting the signal generator slightly off frequency, so because of the radio being the same. So I can hear that at 0.3 of a microvolt. So we'll substitute that now for our test instrument speaker, which we may not be able to hear because I've still got that stupid attenuated speaker on it. And we'll go over to the SINAD meter on the inset picture. So, actually it's very good, this. 0.52, something like that. Let's give it the benefit of that. 0.55 microvolts. 10 dB, 0.45, and 20 if it'll do it. It will. I think that's just. Let's go on the other scale. 1.1. That's only to do with noise, it doesn't matter. Right, we'll go back to the speaker we can hear. Well, we'll go back to the internal speaker at the moment, because I haven't unsoldered it. Squelch. So I'm going to put the squelch to full on the radio, and I'll put this on the attenuator so you can see, and even if the curly mic is in the way. So I want 100 microvolts. Well, that's when I'd like it to open. It doesn't. There isn't a hard and fast rule. It isn't right and wrong. That's my experience. It's 3 millivolts, which is too tight. It hopefully will come down from that. Let's look at the sensitivity. So we'll turn the signal generator down to 0.3 of a microvolt and park it in standby. Turn the squelch down on the radio, set threshold, switch the signal generator back on, straight in. Yeah, not quite. 0.45. So although it's too tight at the top end, it's actually performing all right. It needs to be less than 1. And some of these poorly designed sets, I can think of a team one for a start, 2.5 microvolts. Doesn't work around scratchy corners. So that should be S9. That's putting 100 microvolts on the signal generator, and then it should soon go into plus 30, and it does. That is absolutely spot on. That's where it should be. Correct. Doesn't have a meter lamp. Doesn't have PA. Didn't try the mic. Speaker works. Good. RF meter. Just go back to transmit. Pop the squelch on, and it should be 4 bars for 4 watts. It is. Should be 1 bar when it's on 100, when it's on low power, and it is. So at the moment, that's correct as well. But of course, I'm going to upset it all by retuning the set. So it does work well. Deviation's too high, so on a decent radio, that will start to break up on voice peaks. But this is a working set. Now that Maxcom 4E we did was over the top on transmit, so much that it was squedging, as we would say, and that's producing harmonics. Don't think I'm going to have to unsolder the speaker. And the receiver had been, the transmitter had been tweaked up and the receiver had been tweaked down. So although it was doing something like 4.1 watts, it was producing enormous amounts of harmonics. And with retuning, it was doing 4 watts nicely. Right, transmit straight into it, over to the meter. One of these has got adjustable power, one hasn't. Couldn't find my correct tool yesterday. One of these has variable power, and the other doesn't. That's not going in. Can actually, it's quite a big. That's too big. So I need to have it on full power. Oh, sorry, we're on low power. What a wally! Forget that. So this version doesn't have the power preset. We'll come back to that. It was wrong anyway. So we just have to go up the tuning points. So here goes. Are we on the right meter? Yes. So I want to see a difference so that I can see an absolute correct peak. Slightly out. So that's now 4 watts, which we weren't at before, without even going to the next level. We're actually spot on. So I don't need to touch that one, which would be the final power adjust if it was over the top or inadequate. So don't have to touch that. it's now doing 4 watts. So there we go. Let's see where we are on. Not often I don't have to touch the last one. Well, in this case we do, because it's not quite enough as we go up the scale. So what I'm going to do, I'm going to put the set, and I don't often do this, I'm going to put the radio on channel 30. I just wanted a bit nearer 4 watts. So it may be slightly over at the bottom end. So we need to turn upwards for 4 watts, which I've now done. Okay, so back to channel 20. It's now 4.03 or something like that. Let's look at channel 1. Yeah, it's going to have to come down. So let's get a better average with this one. So is it down or up? Up. So I've got 4.1 now at channel 1. And I've got 3.95 at channel 40. And I've got 4.01 at channel 20. So 3.95, 4 watts, 4.05 watts. So they're not going to come around and confiscate your rig for being for being a 20th of a watt over. And like me, they'll be using a commercial test set if anybody's ever inspected, like this is, not a Zetagi hobby meter. So if you put this on a Zetagi meter, this would read somewhere around 7, 7.5. But they're not real watts, they're Zetagi watts. I don't like that being on an angle. There we go, we're done on there. So now I messed up the low power setting, which needed adjusting anyway. So let's look at that. I've now managed to get 2 watts on there, which is ridiculous. Get it to 400 milliwatts, so it's as it should be. And there we are, 400 milliwatts. Back to full power. Let's look at the meter. So it should be 4, and on low power it should be 1. It is. So it still doesn't need adjusting. Remember rightly, it's the back one there. I'll tell you what, let's adjust it for the laugh anyway. So on low power, I need to adjust it. Remember, I'm saying low power, not on high, for 1 bar, which is where it is. So if I do the right preset, it's not the right tool, is it, that? This isn't the right tool. There you go. So on low power, it wants to be the 1, which is exactly what it was. Let's go back to high power and it should be all 4. So there you are. So we've got low power, 400 milliwatts. We've got meter. Deviation I'll do later with the other test set. Let's look at receive. So we'll go back to the other test instrument 1. Perhaps next Christmas I'll change the speaker back. And what we're looking for is to put 100 microvolts on the signal generator, and we want the oscilloscope on so that we've got the best waveform of recovered audio from the detector. The detector is going to be this one. So let's look at that. It was absolutely spot on where it was. Right, we'll go to the SINAD meter and just see whether we can get a little bit more out of the receiver, or whether, as presented, is its best performance. We're already better than spec anyway. So we'll start with the front end. Let's drop it to about 4 dB, so the receiver isn't being oversaturated, because of course FM has a capture effect, doesn't it? So worse. You know what? We've just gained some. So I'll drop the attenuator, move on to the next one. Now that one was spot on. I'm going to go back on the first one. Because it can be interactive. Remember, the factory doesn't have time to do this. They go through once. When it hits the line, on moves the radio down the conveyor belt. Probably give them 15 seconds to do the tune-up. Well, we have gained some. We're not touching the VCO. Right, let's get a new reading. So for 12 dB, we now have 0.33. For 10-bit dB, 0.285. And will it still do 20? Yes, it will, and it will now do it for 0.9. So let's look at the squelch. So turn the squelch to full, and one of these is the squelch preset. Let's bring that screwdriver back. I'm going to probably have to get another. I don't know where the tool's gone. It's probably on the floor, but there's no hope. One of these is deviation, one of these is squelch. Wallow. That was deviation. Wallow. So I've set that right, but it's probably wrong on the test set. So that's squelch. I could have got the paperwork out, but it, you know, it is so quick to find them anyway. So it hasn't come through at that end. Hasn't come through at that end. So I'm going to step up the level. I'll just put this on the attenuator to see what I'm doing. Now it's come through. So the preset to the left is at its most sensitive. So although I like it to be 100 microvolts, I say there isn't a hard and fast rule, and this particular radio is 250 microvolts. So now at the sensitive end of things, part the signal generator back 0.3. Set squelch. Once again, let's go back to a speaker we can hear. Set the squelch. Signal generator out of standby. .37. So that's now done. So our S meter is that one there. It was already okay, but it may not be now that I've retuned it. No, it's not, it's too high. Just going to have it not quite on the plus 30. So the slightest signal more gives us plus 30. So that's redone. But it wasn't wrong in the first place, but retuning it made it wrong. Frequency. So we'll key it up, look at the signal generator, the frequency counter, let's go to the left. And that's the correct way today. No, it's not. That was false security. Let's go to the right. Couldn't be either way. There isn't a hard and fast rule of how the crystal feels today. See if we can get one more out of it. Not three more. That's nice. Just over. So remember, they drop with age. So I'm actually going to turn this signal generator off, because it says we're now at the correct deviation. I'll turn picture in picture off because we're done with that. I'm just going to plug into the test set on the bench behind me, which is a quartz lock 2828. Can't do CBs on that because the signal generator doesn't do 27 megs, but the other tests like the deviation meter and frequency counter and power meter do go down to 27 megs. What? He's spot on. So, would you believe it? The Marconi test set today is in a good mood, and its deviation meter is spot on. Yeah, we all know it needs the capacitors doing in it, but I'm too near retirement age to worry. When there's other instruments around. We do have a kit which Noxyman produces for building a SINAD meter, and Mr. Chippy is going to be doing that next job. So, one thing I failed to do, I have to put the test set back on, and that is the current consumption is now 1.03 amps. And it's 2.2 to 2.5 kilohertz. We brought it down from 2.8. So too loud, man, too loud. We'll just plug his mic in. I'll put my walkie-talkie on, so we're monitoring it, just to make sure this works. Testing 1 2, testing 1 2. It does work. So we'll compare that on the air test. Tomorrow we'll carry on with the York 867. We've spent actually all the sessions for 3 days. I can't work on CB radios all day because I'm an organ builder. I have to build organs. But so the two-way radio servicing is kind of in between. And do you know what? When I did the organ building, it was a 7-year apprenticeship, and then with the two-way radio, I was already an electronics engineer, which I did college for, but I kind of had to do sidestepping things. And of course, to do work on two-way radios, you've got to either be amateur radio intermediate or military or civilian equivalent. And I've done civilian equivalent as well as being Class A amateur. So that's the qualification for two-way radios, separate to being an electronics engineer. But I've actually got more qualifications in servicing video recorders. So something I don't do a lot of, because I never thought there'd be a day that video recorders were going to end. And I know, it can be great fun having these things for nostalgic reasons. But I just thought this would be the thing forever. And I said to Mr. Chippy in the 90s, one day we'll end up with solid-state video recorders, and we blooming well did. Right, I digress. There we are. There's our mic. We'll put the lid back on. So that really was a retune and test. I've got great faith that this is going to work really well. So when you look at the figures of when you look at the figures of the D version, where we've got 0.33 microvolts here, and it started at 0.55, they're normally somewhere between 1 microvolt and 0.7 or something like that. So people joking will say the D stands for deaf, and it's not deaf, but it's not as good as the previous version. We only compare that to something like I keep coming back to this, the Cobra 29, whatever it is, which looks really swish and looks like a Cobra and is expensive but doesn't work very well. You may have one and you may think it's fantastic, but we've got two, and we've seen a couple of customer ones as well, and they've all been between 2.5 microvolts and like 1 microvolt for 12 dB SINAD. And it's the only time I've said to a customer, you know, the set's not faulty, but it is deaf by modern standards, and a preamp will actually help you in this circumstance. So that's the only time I've said that. But I can understand people liking them. 9 actually lines up somewhere near. Put it on the aerial, have a flick round, see if there's any good buddies out there. That was so funny yesterday. Somebody was talking, really, probably at Nottingham on the best burner, and they're going, oh, Maxcom 4E, they're crap, they are. And I'm there on with the Maxcom 4E, which was anything but crap. Perhaps to him, anything legal's crap. That's probably basically it. Well, we know how sensitive this set is, and I think they're all still having their lunch. One niner, Roger. I'm actually making sure I really am on the aerial. You know what, you'd have thought that was as deaf as a post, but it isn't. It's going to work really well around Scratchy Corner. So there we are. So I'm going to battle on with this York 867, and we will have done all of Alan's repairs. We can get them back to his intermediary then, probably on Friday. But I say this is his York 867, and we've taken the channel selector board out to put in the donor chassis, because I said before, his chassis, all these black bits, are corrosion, and the fact it doesn't receive may be a fault, but it may also be the printed circuit. The printed circuit should look like that, and this is a picture of our stock set. You know, and you can just see it's green and soldered, and this is green and black, and the black's corrosion. So it's probably lived in a bucket of water for a year. But there you go. It's going to get sorted, but by using what was a scrap chassis of ours. It's been a lot of work, but I want to do it for him because they're an unusual set. But just be aware, they're a Murphy DS602. There's a bit of a difference on the front, but they don't just, you know, not quite the same, but the chassis is a Murphy DS602. So here we are, thanks for watching. Baby Midland, 77104 UK from August '89, and it worked a treat.